Do you guys remember those? This meeting is now recorded all the way from, what is it, September? September, that's right. Oh boy, deja vu moment a little bit.
Yes.
All right. Let's see. I gave you a video lecture of 3.5 about this guy doing the video for it. How about this? Raise your hands. That was great. Halfway, like whoa, or like we did not understand whatsoever, Mr. Njiu.
Yeah, it was okay.
It was pretty good.
Yeah.
Okay. Cool. Let's see. So for today, I was thinking of want to get your feedback as well. Are you guys pretty much ready for a chapter 3 test?
No. I was trying some of the 3.5 homework, and there was just some problems that I felt like I probably could have done, but it was just a little bit confusing.
Okay. No problem. Thank you so much for telling me. So how about this here? Today we're going to go over any homework questions. And then my question also is, did I send you guys a study guide for the test?
No.
Oh, okay. That's not a good thing. So let's do this here. Course of action. Go over homework questions today. I send you guys the study guide for the test. Friday we come back. I may give you like a mock sort of test sort of thing on Friday, just to make sure we're all good to go, and test on Monday. Will that work?
Yes.
Could we do more questions on Friday? Because I think that a lot of us aren't like caught up, I guess.
Yeah, gotcha. So let's, thank you so much, Greta. We'll switch it around some more. We could do that. How about this? I'm going to throw questions at you from chapter 3 and see how we do that. Are we good? Will that work? Will that be better?
Yeah.
Okay. So today, let me give you like a mock-ish, just not like a full-on practice test or something like that, but I'm going to pick problems, which I did. I picked problems from chapter 3. And just see how we do as a class. We're good? All right. Do we want to handle any just any homework questions that are sort of maybe through 3.4 or something else like that? Because that was the easier sections.
Yeah. 3.4 was fine for me. And 3.5, there was stuff that he didn't like explicitly talk about in the lecture, but once I read the chapter intro, I could do it so far.
Okay. Gotcha. So let's do this here. Any homework questions, or you guys want to take an extra day or two to work on them?
Probably not next week. Yeah, I think it's you.
Yeah. Okay. So let's do this here. Let me show you what I have as far as what I'm going to send to you guys. This is the study guide for chapter 3. Just to go over it together real quickly here, and then we go from there. So back to 3.1, do you guys remember the reference angles? Reference angles are things that go away from the x-axis. They're always going to be positive, and it doesn't matter which quadrant you're in. And then 3.2 is all about radian measurement, and so conversion between the two. And then also starting with the whole concept of trig functions using radian measurement. Then we got up to the unit circle, the third definition of trig functions, and we started using those. And then we got into area of, area of a sector and length of an arc inside here. So no non-calculator questions for this one, for those two sections here. Going on to the calculator questions, I know I'm going to kind of going fast here. Calculator questions to the nearest, so same thing, reference angle, but now to the nearest 1/10 of a degree. Conversions between the two, but kind of in your mind here. So reference angle, radian and degree conversions, trig functions using radian measurement, arc length, area of a sector, and then this whole concept of velocities. Okay, are we good there? At least kind of put you in the mindset of what we've studied so far. There. All right, the honor questions is going to be if you can go back through your book and actually prove the area of a sector formula. And so let me see where it is in the book. So you are just mimicking the proof for it. And it is, the start of it actually starts on page 143. And so honor students, you may just want to take a look at that page. It's very bottom 143, and then it goes up to the next page, and then you sort of start the proof for it. I will say that is just one of 4. The setup is, you could set it up differently because it's just a proportion, but I'll let you guys ponder that. We'll hopefully on Friday, if you need to ask questions about it, we can do that. Okay. And some other application questions. A little tiny bit more tough than the Canon students, but should be able to get through it. Usually I try to throw something that you've never seen before, but it still applies to what we've done. So that's kind of that application problem. All right, any questions on this? I will send this to you guys right after I finish my classes today.
Wait, so is the test on Wednesday then?
I'm just assuming tests would be on Monday.
Oh, okay. So Friday we're reviewing more. and then-
Yeah, so you guys have the study guide in front of you on Friday, and then we'll take any homework questions on Friday, and then we'll go from there. Okay, are we good there? All right, so going through the study guide right here, I'm gonna just kind of, sorry, congestion. I'm gonna throw some problems at you. We good? So let me new share. I'm gonna jump to this one right here. All right, and hopefully you guys see a PowerPoint.
Yes.
Thingamajiggy? Okay, perfect. Okay, let me stop my video. I'm gonna redo my computer here so I can write. All right, so let's jam. So I'm not sure if you want to treat this as a like a mini practice test-ish sort of thing. I'm gonna write down some problems, give you guys a little bit of time, try it yourself. You can ask the person next to you. If you're stuck, just don't do it on Monday, because then that'll be cheating.
Wait, this one. I didn't do that. No.
We'll all together be working on the test.
Yeah.
And
That's okay,
Oh my gosh, that would actually be so fun.
Nice test.
He's like, you guys did worse together than.
Yeah, I know.
Yeah.
I was gonna say.
So we still don't have any.
I don't know, what should we call it here? Let's see, chapter 3 stuff. How about that? Chapter 3 stuff. And let me get a pen that works a little bit better here. Pen. Where's my pen? Okay, that's the only pen that it likes me to have. Okay, let's go for it here. So, mock chapter 3 test, here we go. I'm gonna start writing down the stuff and maybe like 5 per page or something. You guys can start on the problems already. We'll go back through them to do them here. And so find the find the reference angle. Are we good? Convert to radian or radians. Okay, so these are the non-calculator ones. Okay, and all yours there. And this is just for you guys to practice, see if you guys can do it yourself here. This is non-calculator. I think I'm going to switch between calculator and non-calculator just so the sort of the theme is the same. And I am going to try to figure out how to, oh, there it is, okay. Let me add a different pin color here. Do, 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 do. Huh. There it is. Okay, now I like it. All right, are we good there? So reference angle to A, can I pick on people? Ah, no, you guys are too small. And so 243.6 reference angle, anybody want to try it?
I got 63.6 degrees.
We are in quadrant 4, somewhere down here. So that means we're just a little bit past the 180 marker. So the question is, how far are we past the 180? So then it's just a subtraction like this. Nope, the other way. 243.6, there you go. And that looks about right, 63.6. Awesome, good job. That is Corinna.
Yes.
Awesome. Convert to radians. I think I am going to pick on people here. Let's see. Corinna was on the side. Hayden, I think, is all the way at the end. Is that right? Hayden, is that you in the red shirt? Yeah. Awesome. Okay, all yours for the second one. And then we'll have to do it this way. Amaya, you're in front. You get number 3.
Okay.
We'll kind of work our way through the class, and you guys have to tell me if I miss anybody. So all yours, Hayden, converting number 2. And just tell me the process that you go through. Sorry, let me turn the volume up. I'm not sure if you're speaking, Hayden. I gotta redo my volume here. Okay, now we're good. And you can call for help, no problem, if you need to.
Yes, I haven't finished it yet, but I think the way you would do it is you'd multiply the negative 36 degrees by pi over 180 degrees, right?
That would be great by me. Yeah, and what you guys know, just a quick little thumb, the degrees go away because you have one on top, one on the bottom. And then at that point, then it's going to be simplifying as much as you can here. So I'm thinking, let's see, 36 and 180. You know what? I think actually it has 36 in common. Because 18 and 36. Can we divide this guy by 36 and this guy by 36? How many times does 36 go into 180?
I think 5.
Yeah.
5. So perfect. So negative pi on top, divide by 5, and I think we're good. So either this way or this way. Negative on top or negative in front of the fraction. Boom. Coolio. Next one, Amaya, I think.
Yeah, I got 660 degrees. That's what I got.
I agree. Tell me.
Yeah. And then I did it by multiplying it by 180 over pi.
In this one, notice the degrees on top because you're kind of putting in the degree now. That's the way I always remember it in my mind here. Sometimes you have pi's that cancel, sometimes you don't. And let's see, 3, I would rather divide first. So 3 goes into 180 first 60 times, and then 60 times 11 is 660 degrees done. Cool, okay. Let me jump to, okay, are we good there? Any questions on 1 to 3? Let's jump to the next ones here as we're following the study guide. Let me jump to the calculator portions with the same kind here, because that'll be easier. Oh, the draw one, right, that's what I need. Number 4, I believe, that's what we're on.
Yes.
Ooh, I like this pin. This pin is darker. Can you guys see the screen better? That's right. Can you guys see the screen? Convert to degrees. Let's see. Let's go nearest 10th is fine. Let's go like that. How about that? Boom. All right, converting to degrees. Probably have to use a calculator because notice there's no pi in here to cancel off. Second of all, there's no degree values next to the negative 2.4 and 1/6, so you know you're in radian measurements. So let's see. Give you guys a whole 30 seconds to solve it here. And let's see, Amaya, who's in back of you? I think Rylan is at the end. Who's the?
Haley's right behind me, sorry.
Sorry, Amaya, say that again. Who's
Haley's right behind me.
I'm gonna try to. Oh, I can make it bigger. Okay, I'm playing with the camera. There it is. Oh yeah, that's just so cool. Oh, it only goes so far. Oh yeah, so I'm playing. The teacher's playing with the camera. That's all. Okay, Amaya, sorry, I didn't get who is in front of Rylan.
Haley.
Haley, okay, that's cool. Okay, Haley, hello, welcome back to the class. How you doing? There, got caught on camera. Okay. So Haley, you got 4. Rylan, you have 5. And Georgia, you have 6. We good? And so any one of you guys, all yours for the answers, and then how you did it. You have to do it by calculator, obviously. Also, tell me if you do not have a calculator, we can skip you as well. So Haley, I don't know if you ready for number 4.
I'm not entirely sure I did it right, so.
Uh-huh.
Yeah, can I have help because I'm not entirely sure.
Okay, no problem. No problem. Thank you so much. Anybody on the calculator? You are just going to punch in, and let me put you guys. I'm having your camera down the side here. Take a negative 2.4. It is still a negative, and that's okay. Or just put the negative in later. So 2.4 times 180. Once you get that, divide by pi.
Oh, okay, so it'd be 137.
All right, so our final answer, sorry.
Negative 137.5.
Okay. Others agree as well? Are we good with that?
Yeah.
Okay, and the answer that I have on the board is totally wrong right now.
What?
And then if you put this little guy right over here like this, now it's totally correct.
Wait, we couldn't see what you did.
Gotcha. Okay, I just put in the degree.
I was like, oh, you just told us.
27.5.
Okay, sounds good. Rylin, all yours.
7.3.
We did this in class as well, but I just wanted you guys for you guys to understand. 1 radian measurement is it 57.3? Okay, that's cool.
I know that now.
Yeah.
All right, Jordan, all yours for number 6. What did you get?
I got 343.8 degrees.
Okay, are we good with that? Everybody agreed with that one? Jamming, okay. Calculator ones are easy. Okay, that's too easy.
I disagree.
Did Grant say something over there?
It was Adrian.
Okay, going back the other way, just real quick here. Convert to radians. This is not so fun. No need to take the time to do this here. Nearest 100th for radian measurements here. Nearest 100th. So 144.3 degrees would be 7. And not much you can do there. That's the same exact process here. 8 is negative 289.7. Okay, so let's see. I get to get names here. So Georgia, who's sitting behind you? I think that's Grace.
Yep.
Okay, Grace and Nicholas, all yours for those. All right, everybody else has to do it too, though. Not like you just wait for them to give the answer.
Okay, here was it? Okay, would I do 114.3 times pi over 180?
Perfecto. Yep, exactly.
1.99.
How much did you get? 1.99.
And then it was
1.994.
4.
Okay. Near 100th, but that's okay. It works the same for these guys. We could do that. All right, real quick, I want you guys to notice a little something here. Notice that 1 radian measurement is about 57 degrees, right? So if you're at 114, 115, 120, right? You're somewhere close to the 2 range for radian measurements, right? That's kind of seeing that aspect there. Okay, Nicholas, all yours for this one.
So I believe I got negative 5.1.
Give me 1 or 2 more decimal places.
Okay, well, I rounded to 1, so it's negative 5.0536.
Right there. We're gonna go to thousands, hundredths, hundreds. So you guys change the direction on me here. Nearest thousands is fine. I assume that you guys know how to, place value and how to round off. So we're good. Okay, are we good with those? So now, those are easy. Let me jump back to,
So now we're gonna get the hard one.
that's why I started on the right side of the room. So when I get to Grant, it'll be more difficult.
Yeah, Grant's right now, so you're gonna want to make it difficult now.
Oh yeah, here we go.
Yeah, that should be the easiest one because we just did it. It's definitely not. Yeah, me either. Oh.
Let's see. Is there anybody sitting in front of Grant?
Nope.
Okay, so it's just Grant and Zechariah, right?
Adrian is behind me and then Zechariah.
Say again.
Adrian is behind me and then Zechariah. Hello.
It's Grant, Adrian, Zechariah.
Grant, Adrian, Zechariah. Okay, gotcha. Okay, yes. 3 guys on the left. All right. 8, 9, 9. Let's go with 9. Let's see. How can I make this fun? Fun for me, I mean.
You just ask for help. I'll program my class immediately after this.
All right, find the length of the arc. Here's what I got here. R is equal to 5, and I have myself 55 degrees. R is equal to 2, and theta is equal to pi over 6 radians.
Oh wait, I think I actually did take notes. Oh my God, I did. Oh, that really did.
All right.
You're also proud
I
of
took
me.
dating your notes.
So let's see. All yours, Grant, for the first one. Adrian, you get the second one here. Find the length of the arc to the nearest what? We'll go to nearest hundredth again. It's fine.
Hold up.
All right. Arc length formula, anybody? How about that? Let's do that. What is the arc length formula? I think it's S, isn't it? S is equal to something?
R, S is equal to R theta.
R theta, yeah. And there's one little special thing that happens is theta has to be in radians. Okay, that's one little piece there. That's all.
Wait, you got it.
So are we all right to use the calculator?
So Grant, I'll do the tough one for you. I'm going to put in the 5 for the R.
It's 4.99, I believe.
4 point. Okay, let me go over here on the side though here. Hopefully you did this first though. 55 degrees, right? Multiplied by pi divided by 180.
Yep.
What did you get for that value? Or you just plugged it all into the calculator?
It's 0.959 and some other stuff.
Ah, okay. You plugged it all into the calculator. Is that right?
Right.
Okay. So if you're going to do that, you might as well do this here. So don't do this off to the side. If you're going to do it by calculator, then you're going to have to plug in everything all together, all at one time. So it's going to be 5 times the 55 times the pi, and then the divided by 180. Because if you start doing this on the side and then start writing it in, then you're going to get off by digits.
And I actually I did basically that, just in different parts, because I just multiplied it by the answer.
Okay, And sorry, what did you get for the answer, Grant?
4.799.
Oh, okay, 4.799. Awesome, that works. Usually also this will be given in some kind of units or something like that, so it works that way as well. Okay, Grant, awesome. Thank you so much. Adrian, now you're the next victim. I'm sorry, person to go.
Is it pi over 3, or am I completely wrong?
You are.
You're completely wrong, Adrian. You're ashamed of yourself.
Yeah, this one, we go here, right? And this piece is just that right there. So that's an exact value. Works well, works fine. So I'm not sure, like number 9, I might have, just to pick on Grant a little bit more. Did Grant leave? So I was like, man, I could pick on him, say, give me the exact value for number 9. That would have been fun.
Can do it when he gets back.
Absolutely. There you go. So, hey, Grant, without a calculator, number 9. So you guys remind me of that one. So one more, area of sector, and then we'll jump to the trig functions here. So this is number 11. Area of sector. Find area of sector. And let's see what I got here. So radius is equal to 11 centimeters. And an angle formed of 25 degrees. And to the hundredths place. Okay, are we good there? So find the area of sector to the hundredths place. I have a circle. Radius is 11 centimeters and 25 degrees is about maybe like right there. So I need to know that piece right there. Oh, Grant, how you doing? Glad you're back.
We have more work for you.
Number 9, the way I wrote it, number 9 was in the non-calculator section of the test. So, can you give? I'm not sure if it's just to torture you, or is actually a legitimate question. I'm still struggling in my own mind. So if you can give me the exact value. In lowest terms, of course. Okay, and Zechariah, just to torture you a little bit here, all yours, area of a sector, hundredths place. And then we need the area sector formula. Anybody know the area sector formula off the top of their minds here? I think it starts with an A. I think it has a 1/2 inside it somewhere.
Yes, r squared times.
Okay, and then again, theta in, oh boy, in radians again. Now, Zachariah, I'm not going to torture you like I did Grant, so you could use a calculator for it. Just need to tell again. Yeah, and theta is the toughie right here. Theta is going to be, again, you can plug it all in one shot. It's going to be 25 times pi divided by 180. Now, kind of careful if you guys are using calculator, know that you have to multiply the 11 times 11 first because it's order of operations. So, Zachary, I'm not sure if you have a calculator with you, yes or no? Sorry, I can't hear all the way from the back of the room. Amaya, what did he say?
You said yes.
Okay, perfect, okay. So tell me the answer after you plug that all in.
Should be 26.40, whatever units.
Whatever units, okay? They're called whatever units, centimeters squared. Okay, I think that's pretty cool. Okay, guys, was that okay for just a redoing a few things in chapter 3?
Yes.
Okay, let's get to some fun stuff. Some application questions now of this stuff. Number 12, and this one kind of goes out for anybody here. Try yourself. Maybe we'll do like a 1 minute try it yourself sort of thing. 12 or 11? What are we on? 12. Okay. Here it is. You guys ready? It says a car wheel has a radius of 13 inches. That's cool. Normal tire. That's cool. So question is this: what angle, or through, actually I should say, which through, what angle does the wheel turn if it rolls forward 1 foot? Chicken scratch, hold on, that's forward. Okay, are we good there? Let's do that one, and then, let me do another one here, just in case you get that one quickly. All right, let you guys try that one first. Think about it. I think you got to sort of think about, is it a length of the arc or is it area of a sector problem? And once you figure that out, then the rest becomes easy. Next. Average linear speed. Okay, I just heard a computer go ping. Is that because it's gonna die on us soon?
I think so.
Yeah, it doesn't.
There, class will disappear. That'll be interesting. I mean, I'm gonna pick on you just because you're closer. The power cords are in the back of the room over there. If you mind grabbing one of them and then bringing it over and then hooking it up so it doesn't die.
I'm gonna have to move the computer, which I think doesn't affect anything. Yeah, that is definitely not staying.
Talk to me.
It's not like clicking in and staying.
If we redo this whole like circus, maybe check it out.
Okay, next thing is there like a tape somewhere on the teacher's desk? And just tape it. We're gonna,
It's like a Windows notification.
Ah,
You can drag that like.
Drag the whole thing.
we're at 68%.
okay. That's weird. So I wonder how come it did that little funny computer noise.
And it says that it's charging still.
Okay, yeah, okay. So let's leave it then if it's all good.
Okay, well.
Sorry about that.
What does that say after miles per hour?
Miles per hour, his.
Well, like, what's the rest of the sentence say?
Yeah. His bike wheel is 16 inches in diameter.
Yeah.
What is the angular speed? I guess we should say which angular speed, and we say it is in terms of revolutions per hour. There we go. I guess that would work. Okay, boom, boom. All right, give you guys maybe like just give you guys 1 minute here just to copy it down and then try yourself a minute or two. So number 13 is about velocities, if we haven't noticed yet here. So just one of those questions to try. All right. Give you guys a minute here. I'm gonna drink my tea real quick here.
His bike wheels.
Oh.
When it's charging itself once.
I think there's another
Yeah,
plug-in that's
there are
on.
cords plugged in.
That would explain why you can. That would explain it, yeah.
All right, are we good? Number 12. Anybody want to try it? Anybody got it? Like, hey, that'd be so cool. I think I figured it out.
So I turned the 1 foot into inches. So that's 12 inches, I'm pretty sure.
Uh-huh. Okay. Arc length or area of sector?
I was like, is it 16?
I did arc length.
Arc length, yeah. So here's the first setup. I think we're going to use this formula for it. And then we're just trying to figure out through which angle measurement. And usually angle measurement, we're going to put them in radians anyways. So all yours, where'd you put what?
So then
Mhm.
I put the angle theta by itself because that's what we're trying to solve. So I did 12 over 13.
Perfect. Okay. That's awesome. I just want to show you something, Corinne. Awesome. Let me just show you just a quick little thing here. So this is the wheel of the car, let's say, right? I gotta draw out the rest of the car. Here's the lights. Yay, ta-da, like that. Awesome spokes over here. And so if we have this car rolling 1 foot, right, from here to here, let's say, this little piece right here eventually becomes the arc length. If you kind of think about it, almost like if there was like some paint on the street, right? It'll just kind of wrap up into the tire itself. So technically we take something that's physical like this. It's a tire on the street. We're trying to figure out the street roll. And we go back and we think about it as this right here. So let's say it started here and we go to here. And we think about it as an abstract concept this way. Are we good there? So that's kind of cool. We take physical phenomena, get into an abstract sort of ideal, and then at that point, now we have ourselves an equation that we can use here. So running out of space, let me go down here. So this is 12. That's the way I would write it. Karina just divided by 13 already. There it is. So 12 over 13 equals theta. And give that to me to the nearest, let's see. I'm gonna have you guys convert it to degrees. How about that? Degrees to the nearest 10th for number 12.
I got 52.9.
Oh, perfect. Okay. 52.9 degrees. It's just about 1 radian. Right, 12 over 13 is about 1 radian. So we do that, then we convert that to degrees. So boom, multiply by 180, divided by pi, and voila. All right, Karina, are we good with that one?
Yep.
Cool. Okay, the fun one here. Cyclist average linear speed during a race is 36 miles per hour. His bike wheel is 16 inches in diameter. So I want to know how many revolutions per hour. What's the angular speed? How fast is the spin pretty much happening on this guy if we're at 36 miles per hour? Anybody with that one?
I chose the linear speed equation where it's v equals r times the weird w.
That's cool. Yep. So real quick here, this guy is a Greek letter. It's called omega. It's the lowercase omega. We just like the Greeks here. So a little quick nod to the Greeks. Okay. And all yours.
Yeah, so I plugged in the linear speed for v, which is 36.
36.
Yeah, and then I plugged in 8 for r because the 16 is the diameter, right?
Uh-huh.
And then I solved for omega, lowercase.
Kind of something like that, right? Okay, one small problem is that I have 36, that's in terms of miles, but 8 is in terms of inches. That's my little dilemma. So I think we got to do something first, yeah? So let's convert 36 miles down to inches. Oh man, this is gonna be fun. You guys remember this? Do you remember something looks like this? This is the way I usually do it. Easiest way to convert units down. So if I say this is 36 miles, and eventually I want it in terms of inches right over here. So all here is give me some conversions here. We're almost out of time, huh? Man. Time goes by fast here. Miles to feet. Are we okay with 5,280?
No clue. Yes, it is.
Feet to inches, 12 over 1. And now I got what I want. Notice because the miles will cancel, the feet will cancel, and I'm now in inches. Perfect. Okay, I need someone to give me 36 times 5,280 times 12.
2280,960.
2280,960, right?
How many inches? Nobody should be going that many inches. This is why I have the miles and not inches. Exactly.
All right, yeah, now are we okay?
I'm not okay, but the problem is.
So on the test, will you want us to have all these conversions memorized?
No, I'll tell you guys if it. Yeah, I'll tell you. Just ask me if that's something that we haven't read. I'm more interested. Can you guys know the formula and use the formula? Okay. Can you guys give me real quick here? Half a minute left. All yours. Give that answer there. What is that divided by 8?
285120.
True?
Yes.
Corinna, sorry, say that again. I think 281.
285120.
And that's going to be the omega value. Okay, I'm going to stop there because we're out of time as well. So let's stop there. Thank you guys so much for participating. Thanks, Grant, for letting me pick on you. All right, guys have a good day. I hope to see you guys on Friday.
Thank you.
So, thank you guys. If someone can ask Mrs. Rain to come in to set up the Algebra 2 link on the Zoom meeting. I'm gonna zoom out of here.